we need some more definitions before we, just so we can discuss and be on the same page. So a confidence interval for an unknown parameter, remember parameters go with populations, consists of an interval of numbers based on a point estimate. The smaller number in our interval is called the lower bound. And the larger number in the interval is what we call the upper bound. And this terminology should be familiar from Chapter 7 and Chapter 8. It's the same terminology we use for discovering the edges of our area when we do probabilities under a normal curve. So in that example in part A, I should say probably part 1 of part A, we estimated the population proportion was between 0.70 and 0.80. So that makes the lower boundary 0.70 and upper boundary 0.80. So the other thing we need to talk about is the level of confidence. And the level of confidence represents the expected proportion of intervals that will contain the population parameter if a large number of different samples is obtained. And we denote the level of confidence by 1 minus alpha times 100%. So essentially what that alpha is if we have our boundaries, our level of confidence is the part in between the two boundaries. The alpha is the part in the tails. So remember, because of the symmetry, each tail has an alpha over 2. So half of whatever alpha is. And this is largely important because it's, part of how this works. But you really just need to know that this is how we denote the level of confidence. So there are 2 ways to write those confidence intervals, and they're equivalent. The first way is to write it as the sample proportion plus or minus an error. And remember, sample proportion is p hat, and E is the margin of error. So for example, a local newspaper recently conducted a poll to determine the proportion of voters that supported candidate A for city council. They reported the results as 53.2% plus minus 2% with 95% confidence. What's the sample proportion and the margin of error? So the sample proportion is 53.2%. We have to change that to a decimal, so 0.532. And the margin of error is 2%, so that's 0.02 as a decimal. So, just as in the previous example, we have the lower bound is 0.532 minus 0.02, which is 0.512. And the upper bound is 0.532 plus 0.02, or 0.552. The second way is to write it as the lower bound, which if we look at what we just did, the lower bound is the p hat minus the error. We say that's less than the population proportion, so a regular p, and that is less than our upper bound, which if you look at what we did, that is the sample proportion plus the margin of error. So if they told us the two boundaries, how would we find the p hat? Well, p hat is the lower bound plus the upper bound, and then we divide that sum by 2. So we take the average. So here's our interval. Here's the upper bound. Here's the lower bound. P hat is exactly halfway between them. This distance and this distance should be the same because p hat's halfway in between them. And that distance is the margin of error. So we can find the margin of error by doing one of two things. We can either take p hat and subtract the lower bound, and that gives us this distance, or we can take the upper bound and subtract p hat, and that gives us this distance. But whichever one of these two you do, they should come out to be the same. And it's a good idea to do it both ways just to make sure that you got your p hat right. So for example, a local newspaper recently conducted a poll to determine the proportion of voters that supported increasing property taxes to provide more funding to the local school system. The paper reported that the proportion of people in the town who supported increasing local property taxes to provide more funding to the local school system was between 46% and 52% with 95% confidence. What's the sample proportion and the margin of error? Okay, well, our lower bound is 0.46, and our upper bound is 0.52. So remember, p hat is the lower bound plus the upper bound divided by 2. So that is 0.46 plus 0.52 divided by 2, which gives us 0.49. To find the error, and I'm going to check both ways, we have p hat minus lower bound, which is 0.49 minus 0.46, or 0.03. And just to check that we got our p hat right, we will do the upper bound minus p hat, which should be the same 0.03. So 0.52 minus 0.49 does indeed give me 0.03. Okay, we'll end this video here, and when we come back, we'll talk about the requirements we have to meet before we can create our confidence interval.